Good evening. This is Arnav Kadhe from team Code of Duty, and this is our solution, Swasthya Setu. I'm just going to demonstrate our demo. So here we are looking at the Swasthya Setu monitoring dashboard. Each of these QRs represents a digitally tracked vaccine vial or a shipment unit. For demonstration purposes, we are showing 3 different possible anomaly scenarios that can occur during vaccine delivery. The first one is a geofence deviation, where a shipment moves up outside the approved route. The second is a pressure anomaly, indicating possible tampering or physical stress on the vial container. And the third one is the most critical factor in vaccine cold chain failure, which is the temperature anomaly. The geofence and the pressure anomalies are digitally simulated in this demo, but the temperature sensing module has been physically built and integrated, which I'll demonstrate live. So this is our live sensing prototype built around the ESP32 microcontroller with a temperature sensing module. Right now it is reading approximately 29.9 degrees Celsius, which is normal for our testing environment. In a real vaccine cold chain system, the acceptable storage temperature is typically between 2 degrees Celsius and 8 degrees Celsius. It is between that range. For our demonstration purposes, we have set the anomaly threshold here to 35 degrees Celsius so that we can trigger the event easily. Okay, so let us first now let us start this demo for our temperature anomaly. And I'll just show you the other things that will change as well. So this is our live readings. Okay, so these the monitoring interface, we have our live telemetry data which updates every few seconds from the IoT sensing device. This section basically displays the current temperature readings, any detected anomalies, the timestamp of the event, and the geographical coordinates where the anomaly occurred. So you can see the latitude and longitude over here. So below this, the system also maintains a live anomaly log, which records each abnormal condition as soon as it is detected. And finally, when a verified anomaly happens, over here you will be able to see a blockchain transaction. Okay, and the system anchors a blockchain transaction which serves as an immutable proof of that event. Okay, so now firstly let us scan the QR code before we start the anomaly, before we start the manual anomaly. So let us see what it shows us. So now just believe that the transit is currently in place. Okay, so now currently it is showing us that the vial 003 is all okay. Okay, so now it is okay for use currently. Okay, so now what we will do is we will start the scenario. Okay, so I'll start the simulation. To demonstrate a real cold chain breach, I'll manually heat the temperature using a hairdryer. Okay, so let us heat it till it reaches above the breach limit. So I'm using a hairdryer over here. You can see the temperature will rise after I bring it on. See, it is now 32. I'll just bring it a bit closer. So as we can see, as soon as it has crossed 35, it is showing us breach not safe, which is also represented by the QR on the demo monitoring page. And when I go back to our like the exact telemetry readings, we can see the anomaly log shows the exact timestamp, the temperature value noted, and also the location information associated with that event. Each anomaly is recorded separately so that the investigators or supply chain partners can understand when and how the cold chain was broken. Okay, so I'll just show you the blockchain anchoring as well. So over here in the live logs also you will be able to see the anomalies happening, and I'll show the blockchain anchoring. So over here we have over here we have the system actually anchoring a blockchain transaction for the event. We'll go on Etherscan, and I'll show you the exact event being anchored. So the transaction can be verified on the Sepolia Ethereum test network, where the event is permanently recorded. Okay, after anyone auditing the system can independently verify that the anomaly happened occurred at this exact time. Okay, and I'll just scan the QR code again and also show you like the information that has been changed. So over here you can see that there was a temperature breach at this particular time and the system was not stable, so do not use. And this will now stay permanently even after the temperature if the temperature reaches back to normal and it is stable now, this will still be permanently logged onto the QR, so that the doctor knows that this particular vial and this particular shipment is not to be used on actual patients. Okay, so another important detail is in the over here you might have seen the QR codes changing. So over here you can see the QR codes changing, but this is only for demonstration purposes, because in actual deployment the QR codes would not change, because the QR labels are physically printed on the vials and or shipment boxes, and each QR code will represent a permanent digital identity. So whenever someone scans the QR, the system queries the live backend status to link to that identity. So the QR stays the same, but the safety status behind it updates dynamically. So what this system provides is a simple way for doctors and citizens to instantly verify vaccine safety, while also giving logistic partners the ability to detect and trace where cold chain failures occurred. By combining IoT sensing, digital identity and blockchain anchored anomaly records, Swasthya Setu helps improve trust, transparency and accountability in vaccine delivery systems. So I'll end my demonstration over here.